Mr. Moore's math class.
Good afternoon, guys, and welcome to Mr. Moore's online flip classroom. And boy, am I excited today because we are going to have a look at how to work with radians and degrees. Now that's right, there's actually another unit that we can work with when measuring angles, and these are radians. Now in today's lesson we're going to have a look at how to convert between radians and degrees and just how easy this process actually is. So let's go through now and have a little bit of a look at an introduction to how to do just this. Let's check it out.
Now, as you've just seen, today we're going to have a look at how to convert between radians and degrees. Now, before we do that, let's just have a look at what we actually know about degrees and what we've covered in the past. So, over here on the right-hand side of the screen, you'll see that in the past we have measured angles in degrees, and that is, there's 360 degrees in a full revolution, as we know. So, if you have a look at the unit circle here, if I start off at the 0 degrees, like you can see, and if I went all the way around, I will have travelled 360 degrees. That's one revolution, which means this over here would be 180 degrees, this would be 90 degrees, and this here would be 270 degrees. But if you've ever had a look at a CAS calculator or any other calculator before, you'll see that we actually can use another measurement to measure degrees, and that is called radians, such as what you can see over here in red, there, like so, radians. Now, in order to just discuss radians for a little bit, what we're going to do is I'm just going to explain what 360 degrees is in terms of radians. So if I start off at 0 degrees and I go all the way around in terms of radians, what that in fact is equal to is 2 pi radians. Now, because that is 2 pi radians all the way around, of course this is going to be 0 radians because you haven't travelled anywhere, have you? So if this is 2 pi all the way around to here, this one is going to be at 180, is going to be half of 2 pi, which of course will be pi radians, like so. And of course at halfway between 0 and 1 pi, of course it's going to be pi on 2 because it's half of pi radians. And this one here, well, it's 1.5 times around, isn't it? So therefore it's going to be 3 pi on 2 radians. So as you can see, we actually can measure degrees in radians as well as degrees. And what we're going to do is look at how to convert between radians and between degrees and go backwards and forwards between the two. Now, you can see I've got some special triangles over here. We're going to cover that very soon. But let's now have a look at how to convert from degrees to radians up the top left-hand side of the screen. So as you can see here, the rule says pi radians is equal to the number of degrees times pi on 180. So for your example, it says convert 50 degrees into pi radians. Alright, well let's have a look at that. In order to do it, I'm going to have my pi radians is equal to, now it's my 50 degrees multiplied by pi on 180. Now of course 50 is going to be the same as saying 50 on 1 times pi on 180, and therefore that's going to get me 50 pi on 180, which of course will cancel down to 5 pi on 18, and therefore that there 50 degrees is the same as saying 5 pi on 18 radians. Now for the next one where it says converting from radians to degrees, well, we follow that formula. So in order to do that, we're going to go the degrees is equal to my pi radians, well that's going to be pi on 6 times 180 on pi. Now in order to do that, I just go pi times 180 is 180 pi over 6 times pi, which of course is 6 pi. Now, in order to cancel that down, well, the pi's are going to go away, aren't they? And therefore, 180 divided by 6 actually happens to be 30 degrees. So, pi on 6 is the same as saying 30 degrees. So essentially, for converting between degrees and radians, all you need to do is follow these two straightforward formulas. So as you can see down here, the questions say, convert the following degrees to radians. Alright, well what I'll do is the first one, and then I'll get you to press pause and do the second one. So if we have a look at 70 degrees, well let's go through and convert that to radians. So therefore, pi radians is equal to 70 times pi on 180. Alright, and now if I go through and do 70 times pi on 180, well that's just going to get me 70 pi over 180. And let's just cancel that down, so that's going to end up getting us 7 on 18 pi, like so. So therefore 70 degrees is the same as saying 7 pi on 18. Now what I want you to do is press pause and attempt the question where it says convert 100 degrees to radians. Remember, when you're done, to press play so you can check your answers out against mine. Excellent, so as you can see here, I've got pi radians is equal to 100 times pi on 180. Now when I do 100 times pi on 180, I get 100 pi on 180. And then when I cancel down by a common factor of 20, well, there's 5 20s in 100 and 9 20s in 180. So therefore I get 5 pi on 9 radians like so. Now what I want you to do is actually press pause and redraw the special triangles by converting interior angles to degrees. Alright, of course, when you're done, press play so you can check your answers out against mine. Excellent, so welcome back. Now as you can see here, I've gone through and written out all of the different numbers etc. on the triangles. So we know that for this triangle here we've got a side length of 1 and 1 and root 2 for the hypotenuse, and therefore this angle here and this angle here will both be 45 degrees. So in order to find out what 45 degrees is in terms of radians, well, we're going to go 45 degrees into radians is going to be equal to, well, 45 times pi on 180. Now 45 times pi gets us 45 pi on 180, like you can see here. Now there's a common factor of 45 here, so therefore when you cancel this down, 45 goes into 45 once, and 45 goes into 180 4 times, so you end up getting pi on 4. So this angle here is equal to pi on 4 degrees in radians. And therefore this one here is also going to be pi on 4 because of course it's the same. So now if I have a look at this triangle over here, the second one, as you can see I've gone through and written 1, 2, root 3, and of course this means that this angle here is 30 degrees and this one here is 60 degrees. So let's first of all convert 30 degrees into radians. So in order to do that, I find out that pi radians is equal to 30 times pi on 180, and of course 30 times pi is 30 pi on 180, and then of course 30 goes into both 30 and 180, doesn't it? So therefore 30 goes into 30 once, and 30 goes into 180 6 times. So you end up getting pi on 6 radians. So this here is going to be pi on 6 radians. And then for 60 degrees, well, I'm going to do 60 times pi on 180, and that's going to get me 60 pi on 180. And of course, 60 goes into both 60 and 180, so you're going to get pi on 3 radians. So therefore, this here is pi on 3. So if I go through now and redraw out my triangles just using radians, well, what I'll have is that this here is equal to pi on 4, this here is equal to pi on 4, this here is equal to pi on 6, and this of course is pi on 3. Now it's essential that you know what each of these degrees is in both degrees and in radians when working with the special triangles.
Excellent, guys. Well, I guess now it's time to have a look at a couple of worked examples on how to convert from radians into degrees. So let's check that out.
So now we're going to have a look at a couple of worked examples on how to convert radians into degrees. So let's have a look at the first one, shall we? We've got 2 pi on 3 and we want to convert that into degrees. So what we're going to do is we're going to say that the degrees is equal to 2 pi on 3 times 180 on pi. Now let's go through and do that. So 2 pi times 180, well that's going to be the same as saying 360 pi, because 2 times 180 is 360, over 3 pi, like so. Now of course the 2 pi's are going to cancel out, aren't they? And that's going to leave us with 360 divided by 3, which is equal to 120 degrees. Now if I have a look at 0.1 pi, well if I have a think about that for a second, I'm going to have my degrees is equal to 0.1 pi times 180 on pi. And now 0.1 pi, well that's the same as saying 1/10 pi times 180 on pi. Now 1 pi times 180, well that's going to be the same as saying 180 pi over 10 times pi, which is 10 pi. Now once again the pi's will cancel each other out, and that's going to be 180 divided by 10 is equal to 18 degrees. So now what I want you to do is press pause and attempt the following questions, that is convert 4 pi on 5 to degrees and also 0.3 pi to degrees. Remember when you're done to press play so you can check your answers out against mine. Excellent, so welcome back. Now as you can see you've got 4 pi on 5 and we want to convert that into degrees, so therefore what I'm going to do is do 4 pi on 5 multiplied by 180 on pi. Now 4 times 180 will get me 720, and of course I got my pi there. And 5 times pi, well that's going to get me 5 pi. Now of course the pi's will cancel each other out, and when I do 720 divided by 5 I'll get 144 degrees. Now for D, where I've got 0.3 pi, well that's the same as saying 3/10 pi, or 3 pi on 10. And when I multiply that by 180 on pi, I end up getting 3 times 180 is 540 pi, and then 10 times pi is 10 pi. Once again, the pi's cancel each other out, and 540 divided by 10 is 54 degrees.
Alright guys, thank you very much for tuning into today's lesson, which was all about how to work with degrees and radians and how to convert between the two nice and easily. Alright, so it's very important that you stay tuned for the very next lesson, because we're actually going to have a look at how to work with the unit circle again, but applying this with degrees and radians and also looking at symmetry within the unit circle. So, of course, like always, make sure you say hi to your maths teacher for me. Mozzie out.